All right, let's take a look at this problem. Here we're trying to find any critical points, i.e. maximum, minima, or saddle points that might occur in this surface graph of this function. So as usual, we find the critical points by setting the two partial derivatives to 0. Here's the first partial derivative with respect to x. Here's with respect to y. Set them equal to 0, and now we have to solve this system of equations. This system of equations turns out to have two solutions. And if you want to see the work and analyze it more closely, here's all the work that led to those. Hit pause if you need to. And now that we have our two critical points, we have to classify them by finding the discriminant and finding out what kind of critical points they are. To do that, we'll need our second derivatives. Here I've taken all of the second partial derivatives, and computing the discriminant gives us this. Hit pause if you'd like to analyze the algebra. And now, what we'll do for each critical point is we'll plug it in, find the value of d, and make an assessment from there. For the first critical point, and I didn't show any work here, I plugged in x equals 0 and y equals 0 into all the information at the bottom of the screen, analyzed it, and discovered that we have met the condition for a saddle point because the discriminant is less than 0 at that point. In regard to the second point, I plugged in x equals -18 and y equals 6 into all the information below and realized that the discriminant was greater than 0 and the second derivative with respect to x is greater than 0, and therefore we have a minimum. Now that we know where our saddle point and minimum occur, we need the points in three-dimensional space to know where they physically are. So we plug in 0, 0 to the function, getting this three-dimensional point, and we plug in the minimum, that function. The work's not shown here, but it did work out to -98 on my scratch paper, and therefore I have that three-dimensional point, and I know the physical locations of the saddle and the minimum.